नमस्ते बेटियों, खुश रहिए. I JVN Muskan Kumari from the Department of Science and Technology, and I'm working here as an assistant professor in JVWU Women's University and Faculty of Education and Methodology. So today I will discuss a new topics with the session name. That session name is building blocks of your Hadoop, isn't it? Building blocks of Hadoop, or in that we are basically study about the name node. Clear? So and also the study the architectures of your Hadoop. So to make it an easy way to understanding to all of you, so we are just going to share a files where the architecture of Hadoop is designed, and from that figures you can easily understand that yes, this is the client, here is the name node, here is the data node, and how these all are working properly, how the data is going to be retrieved, and how we are storing the data, isn't it? So these all the process you can easily understand with the help of an example, or also see the architectures or the diagrams. So for this reason I'm just going to share that files, isn't it? So hold 1 minute. Yes, this one is the. So what is the building blocks of the Hadoop? And in this we are especially firstly defining the name node, then we will use the data nodes, isn't it? And meta servers, what is the chunk server? These all the things. So firstly, what the Hadoop overall architecture is distributed master, or from the architecture consisting of a set of daemons and set of the host programs, and which is known as the name node, data node, secondary name node, what is the job tracker, what is the task tracker, isn't it? So basically what Hadoop is overall, this is a formations of the architecture, isn't it? And this architecture is in the distributed form. So the files whatever storing the data is in the distributed form. So we also said that HDFC, which I have discussed in the previous session, the Hadoop distributed file system, isn't it? So this architecture basically also contains the some host of the programs, which is using the name node, data node, secondary name node, job tracker, and task tracker, isn't it? The name node, data node, secondary name node is divided into stored process classes, process class, while job tracker and task tracker are divided into the computational process class. There, here is the two. One is the process class, another is the computational process class. So job tracker and task tracker is used under the computational. Why? Because they are calculating and getting the information from these all the files. Okay, so here they are working as the resultant, producing as a resultant output. So this is called the that ones. So if we talk about the name node, so what name node is the master node of the Hadoop distributed file system, which itself doesn't participate into the input output task, but also instead gives these tasks to the data node, and it manages, who manages data nodes, manages the all the data of that particular files. Clear? Name node. Now name node, the file system metadata is stored into the memory. Clear? So what is the basic working of the name node? Name node is a master node of the Hadoop, which is basically used to store the distributed file system, and which doesn't itself participate into the input output task, but instead give this task to data node that it manages itself. Okay, so name node, the data file system or meta stored in the memory in name node. Now if we talk about the data node, data node is a HDFS, Hadoop distributed file system node from the Hadoop distributed file system, that is known as the slave system, which is responsible for the actual task performing the actual task of reading and writing HDFS blocks. A large file is divided into the HDFS blocks. I have already discussed this terminology block, isn't it? Block and continuously reporting the status to the name node. Clear? Now, if we talk about the secondary name node, what is the secondary name node? Secondary name node is just like a worker processor and a process used in the cluster to monitor the state of the Hadoop distributed file system cluster. This is basically monitor the Hadoop distributed file system cluster. And it is also not the same name node, that it does not accept and record any real-time changes in the Hadoop file system. Instead, it deals only with the name node and periodically collects the snapshot of the Hadoop file system, distributed file system, isn't it? So snapshot, they are containing the snapshot of their this distributed file systems, and which are primarily used to restore the work when name node fails. Clear? So this secondary name node is used. Suppose when if the name node fails and the whatever the files that is stored in that is going to be crushed, isn't it? So how we will recover that file? So there is a additional here storage, that name is the secondary name node, which stores the duplicate files of that ones. And suppose in case if the file is get lost and crushed from the name node, then we can retrieve that file from the secondary name node, isn't it? So secondary name nodes is same as the worker process and used to cluster the state of the Hadoop distributed file system, and it is not the same as the name node, but it doesn't accept the record in real time changes. Real time changes it doesn't uses that thing. Instead, it delays with a name node. It periodically connect the snapshots. They are connect the snapshots of the basically at that time you are storing the files into the the name node, isn't it? So this is containing that things which request primarily to restore work when name node fails. Clear? If we talk about the job tracker, what is the job tracker? Job tracker is our contact for application and Hadoop also. And when we submit code to the Hadoop, when we submit the code to the Hadoop cluster, it determines the execution plan and including deciding which files to process or not, also assigning the different tasks to each node, isn't it? Which is actually assigned the task tracker, which is assigned to the task tracker and then forwarding to the furthers and monitor all tasks that are running or not. This process typically runs on the primary node of the cluster. So you can see here the architecture of the HDFS. Here you can see that there is a master, another is slave, isn't it? In the master, there is a task tracker, job tracker, and in the map reduce layer, and in the HDFS layer, there is a name node, data node, and here on the slave map reduce side, there is a task tracker, and here is the data node. So you can easily see that the job trackers are forwarding the task to monitors is to the task trackers and also the task tracker at the slave side, and here name node are sending or getting the data from data nodes and also the data nodes whatever at the slave side. So name node is what? Name node, it is a single master server exists in the HDFS cluster. As it is a single node, it may become the reason of the single point value also. Okay, so it manages the file system namespace by executing an operations like the opening and remaining and also closing of the files. Isn't it? Now, if we talk about the architecture of the file system, then it basically the simple architecture which signifies and simplifies the architectures of the system. Now, who name node? Now, if you talk about the data node, The HDFS cluster contains the multiple data nodes, isn't it? And each data node contains the multiple data blocks, and these data blocks used to store the data, and their responsibilities of the data node is to read, write, request from the file system's client, isn't it? That client. Now it performs block creation, deletion, replication upon instructions from the name node, whatever the instructions you are giving from the name node, isn't it? Now, if you talk about the job tracker, so job tracker, the role of the job tracker is to keep the map reduce job from client process the data by using the NameNode. He is basically accepting the MapReduce job from the client to and process the data by using the NameNode. Now, if we talk about the more about job trackers, then in response, NameNode provides metadata to the job tracker. Okay, so now task tracker. What is the task tracker? So it works as a slave node for the job tracker, and it receives task and code from the job tracker and applies that code onto the file. And this process can also be called the mapper, which is basically using or mapping uh, the data, isn't it? So map reduce layer, there is a term here you are saying multiple times, that is the map reduce. And what is the map reduce layer? So MapReduce becomes the existence when the client application submits the MapReduce job to job tracker. In response, the job tracker sends the request to the appropriate task trackers, and sometimes that task tracker fails or timeout. In such case, that part of the job is rescheduled, isn't it? I'm again repeating this one. Suppose MapReduce comes to the existence when the client application submits the MapReduce job to job tracker. They are client are submitting the job to the job trackers, and in response, the job tracker sends the request to appropriate task tracker to handle these jobs, which is sent by the clients. Sometimes the task trackers becomes fail or their times going to be out. In such case, the part of job is rescheduled again, isn't it? So what will be the now the last one, the advantage of the Hadoop. What is the advantage of Hadoop? So this is in which case the Hadoop file system data is in the distributed over the cluster and are mapped, which helps in faster retrieval of the data. So even the tools to process the data are often on the same server, thus reducing the processing time also, isn't it? Now, if we talk about the scalability, so Hadoop cluster can be extended by just adding node in the cluster. So if you want to add more nodes in that cluster, then you can easily scalable that clusters by adding more nodes, isn't it? So it is a cost effective. Hadoop is open source and use commodity hardwares to store the data. So it is really the cost effective as compared to the traditional relational database management system. Okay, now if we talk about the resilient to failure, so then HDFC has the property with which it can replicate data over the network. So if one node is down or some other network failure happens, then Hadoop takes the other copy of data and use it. Normally data are replicated thrice, but the replication factor is configurable. So this is all about your HDFS, basically the building blocks of the HDFS, in which we are basically discussing about the name node. But here we have discussed the name node, data node, job trackers, task trackers, and map reduce layer also. And in your course, uh, these all are in the different sessions, isn't it? Suppose in this session I have only discussed about the uh, what name node, and in the next session we should will discuss about the data node, then the map reduce. But we have concluded this all the terminology into the one nodes because these all are considered under the architecture, so it's not possible to describe this in the differentiations, isn't it? So I have discussed this all the terminology in this session, and please read this from the different sites, and please refer multiple books and also the notes which is available online. And if you have any problem in this session, then please do your comments and query into the comment section box, through which we can understand that you have problem in this uh, subjects and in this session, by which I will solve your query by the informative knowledge, isn't it? And please do some possible questions which will be arises from these sessions, like what do you mean by the name node? Explain this ones, isn't it? What is the role of the job tracker? What is the role of secondary name node? Define the architecture of the Hadoop, okay. And so this all the job trackers, map reduce layer is working, and what is the advantage of Hadoop. So many questions will arises from this session and also the previous session. So please be prepared regarding these all the questions whatever will arises from these sessions, isn't it? So read this carefully, Evans. Thank you.